a tectonic wave. When new material is produced at the ridge, the material moves away from the ridge and can move over the older tectonic material. As the new material moves from the ridge, it can create a tectonic wave. The downward force, or the weight of the material as it moves over the older crust material, creates friction and heat. Friction turns the layer of material between the newer and older material into molten rock. The molten rock becomes the lubricant for the tectonic wave as it moves over the older material. At the front of the tectonic wave, the new material is being forced over the older material. Where there is no layer of molten rock to act as a lubricant for the wave. Where there is no lubricant to help the wave move over the older crust material, there will be more friction and more heat being produced. This will create a bubble of molten rock material, just behind the leading edge of the new material. Once a bubble of molten rock is developed, the tectonic wave is completely formed. The molten material, that is formed just behind the leading edge of the wave, becomes an additional force behind the tectonic wave. It is this bubble of molten tectonic material that produces volcanoes. The bubble of tectonic material becomes an additional engine behind the driving force of the tectonic wave, pushing the front of the wave forward over older crust material. Tectonic waves can be a destructive force on crust material. For example, the wave moving between South America and Antarctica. You can see the tectonic wave that has moved past the continentes. When the tectonic wave passed the continents, it pulled some crust material with it. The wave has actually pulled the southern tip of South America away from the continent. It has also caused some flexing of both tips of the continent's crust to the east. Tectonic waves can be found all around the world. In the area around the island of Fiji, you can see two tectonic waves. One moving to the east past another wave, which is moving south and to the west. Tectonic waves may converge on each other and pass over another wave. A dominant wave may cancel or neutralize another tectonic wave as it passes by the other wave. To the north of Fiji Island, the tectonic wave moving south and to the west has cancelled out part of the tectonic wave that is moving to the east. To the south of Fiji Island, part of the tectonic wave that is moving to the southwest has been cancelled out by the wave moving east. Following the dominant wave that is moving east from Fiji, south to the island of New Zealand, the northern part of New Zealand is being moved to the southeast. However, in the southern part of New Zealand, the wave is no longer dominant to the wave that is moving to the west. This wave is moving the southern part of New Zealand island westerly. There may be evidence of the direction crust material is moving based on the tectonic track. In the case of New Zealand, the northern track is to the north of the island, which means that part of the island is moving to the southeast. In the southern part of New Zealand, the southern track is to the east of the island, which means that part of the island is moving westerly. In the Banda Arc area, which is a set of islands in eastern Indonesia, there are several tectonic waves influencing crust material. Between the islands of North Sulawesi and North Maluku, there are two tectonic waves that are converging on each other. Currently, the waves are pushing material together and will eventually pass each other. For example, in the Central America area, there are two tectonic waves that are colliding and have passed by each other in some areas. The wave that is traveling to the east has moved freely and faster through the Caribbean Sea and past another tectonic wave that is moving westerly. It is moving faster because there is very little crust material to slow it down in that region. This wave is also moving through the northern part of South America, where the crust material has slowed down the wave. The same thing is happening in the country of Mexico. As the easterly tectonic wave travels through the crust material of Mexico, the tectonic wave moves at a much slower rate. The tectonic wave that is traveling west is dominant in the western parts of Costa Rica, Nicaragua, and Guatemala, and dominant in South America in the Peru and Chile regions. However, in the northern parts of the country of Mexico, the westerly wave is losing its momentum and power as it travels through the crust material. The westerly wave has moved further west, but has been slightly stalled west of the country of Panama. As a tectonic wave moves through crust material, the wave is harder to track. The volcanoes, or inactive volcanoes in an area, may be an indication of a leading edge of a tectonic wave, or where the wave was once located. The tectonic wave theory accounts for the forces and geographic features we see on Earth today. The tectonic wave theory deviates away from the tectonic plate theory. The tectonic plate theory was based solely on early fundamental observations. Current GPS tracking of crust material has proven that crust material movement is extremely complex. That crust material moves independent of plates. In conclusion, the tectonic plate theory doesn't support current scientific observations, and we should rethink the tectonic plate theory. Thank you for watching.